Welcome back to the deep dive. We are tackling a subject today that I've been really itching to get into.
Oh, yeah.
Yeah, because it sits right at that really uncomfortable intersection of, high stakes military strategy
Mhm.
and the messy, complicated reality of artificial
The
intelligence.
stuff that makes generals very nervous.
It should make everyone nervous. And I want to set the ground rules right away for you listening. We are putting the Hollywood stuff completely aside.
Thank you.
We are not doing the killer robots thing. We're not talking about Terminator. We're not doing the Skynet scenario where the AI becomes sentient and, decides humanity is a virus.
Which is, I mean, it's a fun thought experiment,
Yeah.
but it sucks all the oxygen out of the real conversation, doesn't it? It becomes a distraction.
It really does, because the real danger is frankly much more boring and therefore much more plausible. Today, we're looking at something far more subtle.
More bureaucratic, even.
Exactly. Bureaucratic confusion that could lead to accidental war. We're looking at a specific kind of cognitive trap that militaries right now are just walking straight into.
And it's a trap because it doesn't look like a mistake. It looks like standard operating procedure.
That's the scary part. It looks like you're doing your job correctly, but if you get this one thing wrong in a geopolitical flashpoint zone, you aren't just dealing with a software bug or a server crashing.
You're right. You're dealing with the start of a war.
The kind of war that nobody intended to start, but because the systems moved so fast, because the logic cascaded, nobody could stop it.
An unwinnable, unintended conflict.
And for this deep dive, we are basing our analysis on a really dense and fascinating paper. It's titled Governance in the Indian Military, and it's by an author named Chandra Nath.
Now, that title, I think, might make some people think it's a bit niche.
Right. Oh, this is just about Indian regional policy.
But it's not. Nath is using the Indian military as a case study for a problem that is absolutely universal. Every modern military is facing this. He just happens to be applying it to one of the most volatile regions on Earth.
Okay, so what is the core problem he's identified?
The core thesis revolves around what he calls a doctrinal category error.
That's a heavy phrase. Doctrinal category error.
It is, but it's the absolute key to this entire discussion. It boils down to the difference between trusting the data you have
Yeah.
and trusting the decision a machine makes based on that data.
Okay, let's unpack that. Because, on the surface, those sound like they should be the same thing, right?
You think so?
If I trust my data, if I know my inputs are good, I generally assume my output is going to be good. It's the old computing mantra, garbage in, garbage out.
Right.
So if I'm putting gold in, shouldn't I be getting gold out?
That's the intuitive leap everyone makes.
Yeah.
And for traditional software, for a spreadsheet or a calculator, it's basically true. You put in the correct numbers, the sum of the bottom will be correct unless the hardware literally melts.
Sure.
But Nant's entire argument is that with AI, specifically in a defense context, we are confusing two fundamentally different concepts: data governance and AI governance.
And we're just lumping them into one bucket.
Completely. Most organizations, militaries included, they see this as one big IT problem. They think, well, AI consumes data, so we manage the data correctly, we lock it down, keep it clean, keep it secure, then the AI is safe to use.
That feels like the default assumption in the tech world, too, not just the military. Secure the data pipeline and you're good to go.
It's the default everywhere. But Nath is screaming from the rooftops that while data governance is absolutely necessary, it is completely dangerously insufficient for AI.
And the stakes he lays out specifically for the Indian Armed Forces are, well, they're enormous.
They're existential. We are talking about escalation risk. We're talking about strategic failure. We're talking about unintended conflict breaking out between nuclear-armed neighbors because an algorithm misunderstood what it was looking at.
Even though it had a perfect high-definition view.
Exactly. Even though the data was perfect.
That, for me, reading this, that was the big aha moment. That you can have perfect, clean, secure, encrypted data, well, the paper calls trusted inputs, and still get a completely disastrous war-starting decision from the AI, an untrustworthy output.
It completely breaks the causal link we're all used to.
Yeah, it feels like it violates the laws of physics or something. You can do everything right on the input side.
And still get a catastrophe on the output side.
So let's get into the weeds here. Why are these two things different? Because usually when we talk about governance, you can feel people's eyes start to glaze over.
Oh, absolutely. It sounds like boring compliance training.
It sounds like paperwork, but here it's literally a matter of life and death. So how does the source draw the line between data governance and AI governance?
The distinction is, it's vital. Let's start with data governance. The paper defines this as being focused entirely on the inputs.
Okay.
Its one and only goal is to achieve what he calls data trust.
So we're talking about basic hygiene, data hygiene.
Hygiene is the perfect word for it. Is the data clean? Is it stored securely? Did we collect it legally and ethically? Is it organized properly in the database so we can find it?
It's asset management. We're talking about activities like what? Data collection, storage, encryption, making sure the file formats are correct,
Yeah.
tagging the metadata.
Yes, all of that. Preventing hackers from getting in. Preventing data corruption.
To use an analogy, and let's sort of expand on one hinted at in the paper, think of a high-end restaurant kitchen.
Okay.
Data governance is the supply chain manager, or maybe the person who receives the deliveries at the back door. Their entire job is to ensure the ingredients arriving at the restaurant are pristine.
So they're checking the crates.
They're checking the crates, the vegetables are fresh and washed, the meat has been stored at the correct temperature, the expiration dates are all good, nothing is rotten, nothing is contaminated.
Okay, so if I'm a customer in that restaurant, I can be confident that I'm not going to get E. coli from a bad piece of lettuce. The inputs are safe. Correct. You have achieved data trust. That is, data governance. Now let's switch gears completely to AI governance. The source says this is focused on outputs and behavior.
Not the ingredients.
Not the ingredients. The goal here isn't data trust, it's decision trust.
So in our kitchen analogy, this is the chef.
This is the chef, and it's not just the chef, it's the chef's state of mind, their training, their judgment, and the recipe they're following. AI governance is about ensuring the chef actually cooks the meal correctly, seasons it properly, and serves it to the right person at the right time.
I see where this is going.
You could have the most expensive, organic, beautiful Kobe beef in the world delivered to your kitchen-perfect data governance rate.
Top-tier ingredients, trusted inputs.
But if the AI is poorly trained, or misinterprets the recipe, or is just having a weird day, he might decide to boil that priceless steak in milk and serve it with a side of cyanide because he misunderstood the instructions.
Or if the chef is just hallucinating, which we know AIs do.
Which AIs absolutely do. That's the whole point. The chef might look at that perfect piece of beef and confidently declare that it's a shoe. That is an AI governance failure. It has nothing to do with the data governance failure. The beef was perfect.
Right, and I think this is where that tech support mindset in large organizations just completely falls apart. We tend to treat AI like it's just a faster, more complex calculator.
Yes.
And if a calculator gives you a wrong answer, it's almost always because you typed a number in wrong. You made an input error. But AI isn't deterministic like that. It's probabilistic. It's making an educated guess.
It is inferring. It's finding patterns. And that's why this category error that Nath talks about is so profoundly dangerous. If you only focus on data governance, you are, in effect, only watching the back door of the restaurant where the delivery trucks arrive. You're checking the clipboards, you're signing off on the inventory.
But you are completely ignoring what is happening at the stove.
You have no idea what the chef is doing.
And in a military context, what happens at the stove is what determines whether or not you launch a missile.
And this is where we have to be crystal clear. In the corporate world, if an AI hallucinates, okay, maybe your marketing campaign recommends something weird, you lose some money, you get a bad PR headline for a day.
Annoying, but not catastrophic.
Exactly. In the context Nath is writing about, that tense, high-stakes Indian military border context, the cost of an AI hallucination is kinetic. It's measured in lives.
So let's move this out of the abstract, out of the kitchen, and onto the battlefield. The paper lays out a stylized scenario, which I found incredibly helpful because it makes this abstract risk terrifyingly concrete. He calls it the nightmare scenario.
It is. And it's important to say that while it is stylized, anyone who follows military technology will recognize that all the components are very real and either exist today or are in late-stage development.
So what's the setup?
The context is a contested land border. Given the author and the paper's focus, we are almost certainly meant to imagine the line of actual control, the LAC, high in the Himalayas between India and China.
So, extremely rugged terrain, unpredictable weather, and a baseline of constant simmering tension between two nuclear powers.
The definition of a flashpoint. And into this environment, the military has deployed what the paper calls an AI-enabled surveillance fusion system.
Okay, we hear the word fusion thrown around a lot. For our listeners who aren't deep in the defense tech world, let's clarify what that means. We aren't just talking about a better camera, are we?
No, not at all. This is much more sophisticated. Sensor fusion is basically the holy grail of modern military intelligence. You have dozens of different sensors all looking at the same area.
Like what?
You might have High-resolution optical cameras, infrared sensors that see heat, synthetic aperture radar from satellites that can see through clouds, maybe even acoustic sensors listening for engine noises, or signals intelligence intercepting radio chatter.
And they're all giving you different pieces of the puzzle.
Right, and sometimes those pieces might even seem to contradict each other. A fusion system takes all those disparate data streams and uses complex algorithms, things like Kalman filters or Bayesian inference, to crunch it all down and create a single, unified truth.
So it's the system that tells the commander there's an enemy tank at these coordinates with 98% confidence.
Ideally, yes. It's supposed to cut through the fog of war and give you a clear picture of reality. So in Nath's nightmare scenario, step one is the success. The system is online, and it's ingesting huge amounts of high-quality ISR data.
ISR being intelligence, surveillance, and reconnaissance.
Correct. And the data governance is working perfectly. The satellite feeds are encrypted, they're high bandwidth, the resolution on the drone cameras is crystal clear. Everything is working as advertised on the input side.
So picture the commander. He's in the command center looking at these big screens. The picture is crisp, 4K video. He's not seeing static or lag. From his perspective, the system is reliable. He trusts it because the picture looks so good.
He has achieved data trust. The inputs are trusted. But then we hit step two, the AI processing. This is where the chef starts cooking.
The black box.
The black box. The fusion system has an internal prioritization logic. It's been trained on mountains of past data to identify patterns that indicate a threat. In this specific scenario, the sensors pick up what the paper calls ambiguous logistical movements.
Which, I mean, that could be almost anything, couldn't it? It's a supply truck moving from one depot to another. It's a troop transport taking soldiers to a new winter barracks. It's a repair crew going to fix a generator.
Or it's the enemy secretly positioning ammunition dumps and fuel supplies for a surprise offensive. It's inherently ambiguous.
A human analyst looking at that same raw data might have the context to make a better judgment.
Exactly. A human analyst might look at that and say, well, the weather forecast says a blizzard is coming in 2 days. Maybe they're just moving supplies to the more sheltered forward bases.
Yeah.
A human understands context, intent, nuance.
But the AI is just looking for statistical patterns it was trained on. It doesn't know about the weather forecast unless it was explicitly included in its data model.
And that leads directly to step three, the error. The AI misclassifies this ambiguous movement. The logic inside the neural network makes a leap. It takes this logistics shuffle and it tags it with high confidence as imminent hostile intent.
And it's not flagging it as maybe a threat, keep an eye on this.
No, it's definitive. The screen flashes red. It gives a high probability score. Attack imminent.
And because this complex, trusted system thinks an invasion is about to happen, it immediately moves to step 4, escalation.
The system's output, its recommendation to the human commander, is rapid preemptive posturing.
Which is military speak for what?
Get your guns ready. Move your tanks and artillery to the pre-planned firing lines. Scramble the jets. Maybe even fire a warning shot or conduct a limited preemptive strike on that convoy before they can deploy their forces.
Wow. Okay, now let's really put ourselves in the shoes of that commander in the command center. We've already established his mindset. He trusts the system.
Deeply.
He knows his data guys are the best in the world. He knows the satellite feed is live and encrypted. The picture is clear. And now this incredibly expensive, highly touted system is screaming at him, attack imminent.
And he has, what, maybe 3 or 4 minutes to make a decision that could define the rest of his life and his country's history.
Does he have the institutional backing, the training, the personal courage to ignore the machine?
That is the million-dollar question, isn't it? If he relies on that output without a separate, robust AI governance framework, without having been trained to interrogate the logic of the model, not just the quality of the data feed, he is overwhelmingly likely to escalate.
Because he thinks he's reacting to the enemy.
He thinks he's reacting to reality, but he's actually reacting to a statistical error buried deep inside a neural network.
It's the ultimate false positive. But it's not your email spam filter accidentally catching a legitimate newsletter.
No, the consequence is a border war.
And once that first shot is fired, the other side, who remember was just moving some trucks to a new warehouse, they see shells landing. So naturally they fire back.
And now you have a hot war that started over literally nothing. A phantom. A ghost in the machine.
This brings us to the specific context of India, which you mentioned earlier. I really want to drill down on why this paper focuses there, because obviously this kind of scenario could happen to the US military or NATO or China, But the paper argues that India has a very specific and dangerous cocktail of variables that make this risk incredibly acute.
It's a perfect storm, really. It's a combination of geography, geopolitics, and institutional timing. The source outlines the operational environment very clearly. First and most obviously, you have the contested borders.
Right, this is not the US-Canada border with a friendly guard and a duty-free shop.
Not even close. This is a border where, in recent years, troops have physically clashed with clubs and stones and improvised weapons. The level of tension is already at a boiling point, 247.
So the baseline anxiety is already sky high. You're already primed to expect the worst.
Exactly. Confirmation bias is a massive risk factor here. If you already expect an attack is possible at any moment, and then the shiny new AI tells you attack coming, you are psychologically primed to believe it without question.
That makes sense. Then the paper adds the next layer, which is adversarial deception.
The enemy gets a vote.
The enemy gets a vote. I love that phrase.
The enemy isn't just a passive object that you're observing. They know you're using advanced surveillance. They know you're using AI. And if they are smart, and we have to assume they are, they will actively try to manipulate and poison the environment.
We're not talking about hacking the system and poisoning the data files.
No, something much more subtle. They might try to poison the physical environment the AI is observing. They could learn the patterns your algorithm looks for, and then deliberately mimic them with harmless activity just to trigger a false alarm.
They can bait you.
They can bait you. They might move trucks in a very specific formation that they know your AI has been trained to identify as hostile. They might use a new type of camouflage that confuses the computer vision models.
We've seen researchers do this in the civilian world, right? Putting a few small stickers on a stop sign to make a self-driving car's AI think it's a 100-mile-an-hour speed limit sign.
Exactly that principle.
Yeah.
Imagine doing it with tanks and convoys. If your adversary can reliably trick your AI into thinking you are under attack, they can effectively force you to escalate at a time and a place of their choosing. They can make you waste resources, reveal your positions, and look like the aggressor on the world stage.
That is an incredibly dangerous new form of warfare, and that leads to the third and most terrifying factor the paper brings up: nuclear-armed dyads.
This is the existential part of the risk equation. India sits geographically between two other nuclear powers, Pakistan and China.
So any conflict has the potential to go nuclear.
It's always in the background. In a conventional war between non-nuclear states, you have some time. Diplomats can get on the phone, you can have ceasefires, you can de-escalate. But in a nuclear standoff, the crisis instability is extreme.
Meaning things can spiral out of control very, very quickly.
In minutes. If an AI error triggers a conventional skirmish on the border, and that skirmish spirals into a broader conflict, you are walking up the rungs of the escalation ladder directly toward a nuclear exchange. The margin for error is effectively zero.
A false positive isn't just embarrassing, it's potentially catastrophic for the entire planet.
And that's not hyperbole.
The paper also touches on an internal factor, which is the Indian military's move toward integrated theater commands. India is in the middle of a huge reorganization of its military structure, isn't it?
It is. It's a massive multi-year undertaking. The goal is to move away from the old system where the Army, Navy, and Air Force all had their own separate commands and move toward a more unified joint structure, similar to what the U.S. has.
Which on paper is meant to make them more efficient and effective.
It is, but it adds a whole new layer of AI complexity and risk. If you have an integrated theater command, you are, by definition, fusing data not just from one domain, like the land border, but from all of them.
So you're pulling in data from the Navy and the Indian Ocean, the Air Force in the sky, cyber commands, space assets, and the Army in the mountains.
It's an interoperability nightmare under the best of circumstances. It's a data governance nightmare, but it's an even bigger AI governance risk.
Why is that?
Because you create the possibility of cross-domain escalation. Suppose a naval AI monitoring shipping lanes spots an unusually shaped sonar contact and flags it as a potential enemy submarine. That data point doesn't stay with the Navy. It gets fed into the central brain of the integrated command.
And the central brain might correlate that with the ambiguous truck movement happening 1,000 miles away in the mountains.
Precisely. The AI seeking patterns might connect two completely unrelated ambiguous events and decide, this isn't just a truck and a weird sonar blip. This is a coordinated multi-front assault.
So a small potential mistake in the ocean amplifies another small potential mistake in the mountains.
And suddenly you have Air Force jets scrambling because a buoy malfunctioned and a truck driver parked in the wrong spot for lunch, and the AI connected docks that simply shouldn't have been connected. The error in one domain cascades, and creates a crisis in another.
This makes the argument for command responsibility just so much stronger. This can't be a problem that you delegate down to the IT department. You can't just have a sergeant in the server room checking to make sure the hard drives are spinning.
Absolutely not. And that is the pivotal mindset shift that Nath is arguing for in this paper. We have to move from viewing AI as a form of technical support to viewing it as a core command function.
That feels like it would be a huge culture shock, a culture war even, within a traditional military hierarchy.
Oh, for sure.
Traditionally, commanders are warriors. They understand strategy, logistics, ballistics, the importance of morale. Now you're telling them they also need to understand, the failure modes of a generative adversarial network.
Well, they don't need to learn how to code in Python, but they absolutely need to understand the nature of the weapon system they are wielding. Think about it like this. Think about artillery from 100 years ago.
Okay.
A commander is responsible for every single shell his guns fire. If he orders a strike on a hill and it turns out the coordinates were wrong and he hits a school, he can't turn around and say, well, the cannon manufacturer didn't tell me it could shoot that far.
No, that's absurd. It's his responsibility.
It is his absolute responsibility to ensure the target is valid and the weapon is used correctly. The gun worked fine, I just aimed it at the wrong thing. That is a failure of command. Nath's argument is that commanders must be held equally responsible for how they use AI.
So they need to understand its limitations.
They need to understand that AI is probabilistic, that it is not an oracle delivering divine truth. It is a statistical guessing machine, and sometimes it guesses wrong, and they are responsible for the consequences of those guesses.
There's also a really important point the paper brings up about constitutional civilian oversight. This isn't just a military problem, it's a problem for any democracy.
It's fundamental. In a democracy like India or the US or the UK, the military answers to the elected civilian government. The prime minister, the president, the cabinet, they decide when the nation goes to war. That's the bedrock of civil-military relations.
But AI threatens to break that chain.
It does, because of the black box problem.
Right. We hear that term black box thrown around all the time.
Yeah.
Let's actually dig into what that means from a technical standpoint, because it's not just a box that we can't physically open. We often have the source code, we can see the math. So why do we call it a black box?
It's a great question, because you're right, it's not about secrecy. It's about comprehensibility. Modern AI, specifically the deep learning models we're talking about, isn't a set of if this, then that rules that a human programmer wrote out.
It's not a flowchart.
It's not a flowchart. It's a network of artificial neurons organized in layers with potentially millions or even billions of connections between them. Each connection has a numerical weight or bias. When you feed an image of that truck into the system, the pixels get converted into numbers. And those numbers pass through these layers, getting transformed by a massive series of mathematical operations at each step until finally an output pops out at the other end that says hostile intent, 99%.
So we can see the input, the picture of the truck, and we can see the output, the warning.
And a computer scientist can even look at the math in the middle. But we cannot intuitively understand why that specific combination of a billion math operations led to that specific conclusion. We can't trace the logic in a way that makes sense to a human brain.
So if the general turns to the machine and asks, why did you think that truck was a threat? The AI can't explain itself.
It can't explain its reasoning in human terms. It can't say, well, the shape of the fender combined with the shadow length looks suspicious. It just says, the result of my calculation on the input data is 99%.
And if an opaque, unexplainable system is the thing that triggers a war, you have effectively broken the chain of civilian oversight.
Completely. The prime minister calls the general and asks, why did we just launch an attack? The general says, the machine told me to. The prime minister asks the machine why. The machine says nothing.
You've essentially outsourced the casus belli, the legal and moral justification for war, to a matrix of floating point numbers that nobody, not even its creators, fully understands.
Which is constitutionally unacceptable in a democracy. And that's why the paper argues that data controls, like encryption and security, are not nearly enough. You need explainability and auditability, which are core tenets of AI governance.
Okay, so we've pretty thoroughly terrified everyone listening. We've established the category error, we've walked through the nightmare scenario, and we've touched on the potential constitutional crisis. So what's the fix? How do we prevent this? The paper proposes what it calls a life cycle-based AI governance framework.
Right. And as soon as I say the word framework, I can hear the collective groan from our listeners. Oh, great, more bureaucracy, more PowerPoint slides.
It sounds like the DMV for missile systems, doesn't it? Is a general in the heat of battle really going to pause and consult a registration log? Hold your fire, everyone. I need to check the VIN number on this targeting software.
It's a very fair critique. Bureaucracy is inherently slow, and modern warfare is terrifyingly fast. But Nath's counterargument is that this kind of disciplined, upfront bureaucracy is the only way to enable safe decision-making at speed later on. You do the hard work in peacetime so you don't have to think about it in wartime.
Okay, so what does this framework look like?
It has three main pillars, and it's a cycle, not a one-time checklist. The first step, the foundation, is registration and documentation.
The paperwork part.
The paperwork part, yes. But consider why it's so important. The proposed rule is simple. Every single AI system used by the military must be formally registered in a central repository to prevent what the paper calls diffused responsibility. Imagine a modern battlefield. It's not just one big command and control system. You have AI-powered targeting pods on jets running one piece of software. You have predictive maintenance algorithms in the tanks running another. The satellite uplink has its own AI for optimizing bandwidth, and so on.
And some of those might be official, approved programs of record, but others might be less formal.
Exactly. Some might be beta tests from a defense contractor. Some might be open source tools that a smart young major downloaded onto a laptop to help with his unit's logistics planning. You have shadow IT on the battlefield.
And if a decision goes wrong, you need to know exactly which system made the critical error.
But it's even more important than that. The registry wouldn't just list the name of the software. It would have to include its training data provenance.
Where the AI went to school.
Beautifully put, yes. Where did the data used to train this model come from? If you are about to go into combat in the high-altitude deserts of Ladakh in January, you need to be able to look at the registry and find out if your computer vision model for identifying enemy tanks was trained on data from, say, the lush green jungles of Southeast Asia in July.
Because if it was, it won't know what snow looks like.
It might think a snowdrift is a camouflaged vehicle. It might think the heat signature of a rock in the freezing cold is an engine. If a commander can look at that registry and see, warning, this model is not validated for winter or high-altitude operations, then he knows not to trust its outputs in his current environment.
Okay, I buy that. That isn't red tape. That's vital operational intelligence.
It's like knowing the effective range of your rifle.
Right.
You wouldn't use a shotgun to hit a target a mile away. You need to know the effective operational range of your algorithm.
So that's step one, know your tools. What's step two?
Step two is evaluation and monitoring. Continuous testing, not just a one-time test in a lab before you deploy it. This part of the framework is designed to address a really tricky concept that people in IT struggle with, let alone the military. It's the idea of data drift or model drift.
We tend to assume software is static, right? If I buy Microsoft Word today, it works the same way tomorrow and next year until I run an update.
Correct. But AI models are different because they are a reflection of the world they were trained on. And the real world is constantly changing.
So data drift is when the world changes and the model doesn't.
That's it exactly. It's when the statistical properties of the real-world data the model is seeing start to diverge from the statistical properties of the data it was trained on. Let's say you trained your enemy recognition model on the enemy's 2020 tactics and vehicle types. But it's 2026 now. The enemy has introduced a new model of tank, and they've changed their battlefield formations.
The AI model is now looking for a pattern that no longer exists in the wild.
Or worse, that pattern might now mean something completely different. The software code of the model hasn't changed by a single byte, but its accuracy, its performance has drifted into uselessness because reality moved on without it.
So how do you fight that?
The paper argues for continuous, rigorous monitoring. You have to constantly revalidate these models in realistic field exercises, in complex wargaming simulations, and critically, you have to test them specifically against adversarial deception. You need a dedicated red team that is constantly trying to fool your own AIs.
So your AI needs to go to boot camp and stay there. It's not a one-and-done graduation.
It has to be in a state of constant training and revalidation. If you aren't actively monitoring your models for drift, you're essentially fighting with a weapon that is silently rusting away in your hands.
Which brings us to step three, which feels like the most critical one: accountability and human oversight. This is where we get to the famous buzzwords like human in the loop.
Right? And also human on the loop. And the source is very specific here, saying that we need to be incredibly precise about these terms because the functional difference between them is enormous.
Yeah, let's really break that down. What is the actual practical difference between being in the loop versus on the loop?
Okay. Human in the loop means the machine cannot take a critical action, specifically a violent one, without a positive, affirmative human command. The AI can do all the work up to the final step. It can identify the target, calculate the firing solution, aim the weapon, and then it stops. It says, ready to fire.
And just waits.
It waits,
Yeah.
and nothing happens until a human operator looks at the recommendation and physically presses a fire button.
So it's not a veto power where the human can stop it. It's an initiation power. No button press, no boom.
Precisely. Now contrast that with human on the loop. This is a very different philosophy. In this model, the machine is authorized to be fully automated. It identifies, it locks, it aims, and it begins the firing sequence on its own.
And the human's role.
The human operator has a preset window of time, maybe it's 30 seconds, maybe in a hypersonic environment it's only 5 seconds, to intervene and hit an abort or veto button. If the human does nothing, the machine will automatically complete the action and fire the weapon.
That sounds remarkably more dangerous.
It is psychologically a world of difference. It puts the human under immense time pressure and plays into a powerful cognitive bias called automation bias.
The tendency to just trust the machine.
Especially when you are tired, stressed, looking at 10 screens at once, and an alarm is blaring. The path of least resistance, the easiest thing to do is nothing, to let the machine handle it. In practice, human on the loop often devolves into human out of the loop.
Because the human just becomes a passive observer, a rubber stamp who only acts as something is glaringly wrong.
Exactly. And the source is adamant that for lethal decisions, especially in that volatile nuclear dyad context, you need robust human-in-the-loop control, and you need traceability.
So an audit trail.
A flight data recorder for every decision. If a commander authorizes a strike based on an AI recommendation, the system must log everything. What data did the AI present to the commander? What was the confidence interval it showed? What other options did it suggest?
So after the fact, we can reconstruct the moment and audit the entire kill chain.
Yes. It serves two purposes. It protects the commander if it turns out they made a reasonable decision based on faulty information from the machine, but it also enforces discipline. You can't just throw up your hands and blame the glitch in the black box. Your decision is on the record.
So let's try to bring all this together. We have the framework. Register, evaluate, and ensure accountability. What is the ultimate so what for that general in the command center? We aren't just giving him more homework and more forms to fill out. The paper seems to be arguing for a fundamental change in his job description.
That's exactly right. So what is the concept of continuous command responsibility? The general's job in an AI-enabled military is no longer just to be a consumer of intelligence that gets handed to him. He is now the active manager of the entire intelligence architecture.
He needs to be constantly aware that the lens through which he is seeing the world might be cracked.
That is a beautiful way to put it. The AI is the lens. It's the prism through which he perceives the entire war. And if that lens is distorted by bad training data, by model drift, by adversarial poisoning, then he is effectively fighting blind while thinking he has perfect 20/20 vision.
And if the AI, by its very design, compresses his decision timeline down to a few seconds, forcing him to act before he can properly think.
That is a command failure, not a software bug. It's the commander's responsibility to ensure that the systems he uses allow for human cognition for judgment. It's his job to push back on the technologists and say, this system is too fast, it's taking me out of the loop, it's unacceptable.
So it's not a tech support ticket he needs to file.
It's a failure of his own doctrine and leadership. The paper reframes this entire idea of governance, not as a bureaucratic compliance exercise, but as a fundamental doctrinal safeguard. It is the conceptual armor that protects the military and the nation from making a catastrophic strategic blunder that could end the country.
We've covered a massive amount of ground here. We've gone from the kitchen of simple data hygiene
To the very complex chef of AI decision-making.
We've looked at the specific risks in the Himalayas, the nuclear context, the black box problem, and this three-part framework for a solution.
It's really a journey from focusing only on input trust to understanding the necessity of output trust.
That really is the bumper sticker for this whole deep dive, isn't it? Data trust, inputs, does not equal decision trust, outputs.
And if you, listening to this, walk away with only one idea, I think it should be that. You can have the best, cleanest, most secure data in the history of the world and still have an AI that sleepwalks your nation into a war.
So before we sign off, I want to leave our listeners with a final provocative thought. We've talked a lot about the technology, the bureaucracy, the danger. But there's a deeper, almost philosophical point that the paper makes right at the end. It's about the idea of restraint.
Restraint under uncertainty. It's such a powerful and counterintuitive conclusion to all of this.
Why counterintuitive?
Because the entire history of military technology for the last century has been about speed. We build AI for speed, we want to shoot faster, decide faster, and maneuver faster than the enemy. It's Colonel John Boyd's ODO, loot, observe, orient, decide, act. The entire goal is to tighten that loop, to cycle through it faster than your opponent.
Speed is life. That's the mantra.
In traditional tactical combat, yes. But the paper forces us to ask a difficult question. In this new era of high-speed, opaque AI warfare, where algorithms are screaming at human operators to escalate every microsecond based on probabilistic guesses, is speed still the ultimate virtue?
Or is the most valuable military trait now the ability to hit the brakes?
Exactly. It might be the ability to slow down, the human capacity to recognize when the machine is operating outside its parameters, to sense when something is wrong, even when the data looks perfect. It might be the moral and intellectual courage to say no to the algorithm, even when it's flashing red and giving you a 99% probability of an imminent attack, because your intuition, your uniquely human context, is telling you this just doesn't feel right.
So the ultimate weapon in the 21st century might not be a hypersonic missile. It might just be the human ability to sit on your hands for 10 critical seconds and think.
That brief human pause for reflection might be the only firewall that saves us from an accidental algorithmic apocalypse.
That is a heavy thought to end on, but a deeply necessary one. It tells us we aren't just in a race to build better machines, we're in a race to build better, wiser commanders to manage them.
Absolutely. The human element has never been more critical.
Thank you so much for breaking this all down. This went so much deeper than the usual AI is scary headlines you see everywhere.
It's a real pleasure to unpack it. The paper gives you a lot to think about.
It certainly does. And to our listeners, don't just take the algorithm's word for it. Check the logic, check the chef, and as always, keep digging.